Alright, Advent of Code 2021, day 9. I'm going to read this and then get back to you. Nice and short in contrast to yesterday. Like, we're finding local minima. So we're going to pass this into a grid of numbers in NDArray. And then we're going to find local minima. Okay, let's do that. So we're going to use nom character complete u8 for each number. We're going to need our line ending for breaking our sequences. We're going to need multi-many one for each individual one. We're also going to need bytes complete take to make sure that we're able to take one byte at a time, and we're going to need parser. Okay, so now let's say let height is equal to take one map 8. So in fact, let's have a look at non-parser docs, and let's look at parser. Is map what we want, or is the maps a function? No, we want like, and then applies a second parser over the first one, and then. Okay, so that's our height parser. Then our row is equal to many one height, and our cols is equal to separated list. Sequence. Is it multi-separated list? Okay, is a separated list of line ending row. Okay, and then in here we're going to say we need to use nom array2 and not NDArray, and I know ahead of time we're already also going to need the slice macro to solve this. Okay, and so then we need to do parser is equal to, we need combinator map res, because reshape can fail. Map res from cols into cols passed input, parser dot input, parser dot pass input. And then for our past input, we have got our map is an array2 of u8. Okay, and so now we need to fill in that. So we're going to say that this is okay, past result. And then for this, we need to do map is equal to array1. We need to bring array1 in as well, because array1 implements from iter. Cols dot into iter dot flatten dot into shape, and now this is where we actually need to do a bit more pre-processing. So let's actually include this. Let's say we've got, in fact, we can get our shape out of our map once we have it, so we need to just compute it in here. Or the phantom E. There we go. Into shape. Now we just need to specify what kind of shape we want. And the way we're going to do that is we are going to say let height equal cols dot. This should be really rows, and then let width equal cols dot first dot get 0 dot map and n dot len unwrap or default. So that's going to give us a and again rows is called rows now. Yep, and then this here we're going to go into shape of width height like that. And into shape can fail. And again, this is called rows. And this needs to be wrapped in an OK. Which gets closed here. You are closed, and then you are closed. There we go. The trait bound from I32 to usize. Why is it trying to take an I32 of anything? I'm missing a comma. Okay. That's causing all sorts of problems. I'm also going to delete that buffer. There we go. Usize is not implemented for I32. Why do you care about an I32? Is what I'm wondering. Oh, okay, that's dumb. Take one usize. Okay. Cannot figure out error parameter. Into shape does return an error, right? Oh, you know why? Let's do it the way that doesn't require yank to end. Yank to end. There we go. Dot map. Map past input map. Close the function, close the map. And it's called into shape. Right, okay. So, unused imports, that's fine. Okay. So next up, that should be our input. Let's find out if it is by just debugging input map and looking at some test data. So we're going to say input is equal to a raw string being trimmed like we normally do. And then let's grab that and put that in there. And then we're going to assert task1, assert task, pass task1, input nothing, and we'll run that test. 2199 to okay, we've got our width and our height the wrong way around. That's fine. Swap them here for height, width. I can never remember which way around things go with this. 2199. Yep, that looks correct to me. Yeah, first index is height, second one is width. That makes sense. Okay. Yes, so there's our map. So now what we need to do is we need to find all of the local minima, and the way we do that is we need to do a mask where we care about numbers to the left and right, and the numbers above and below lower than any of its location. Okay, cool. So the way we're going to do that, is there a mask in ND array? Because that would just be nice. Mask? No. Okay, well we can use slice. And we can iterate basically using the position. Yeah, so we can say and so this is going to be a, let's just call it a U32. That should be big enough. I doubt a U8 will be, but a U32 should be for our big input anyway. Yep, so this is going to be input.map .iter dot iter, we want indexed iter. Okay, and now an indexed iter gives us a shape, height, width. So that is yx e. Okay. And now in here we just need to check relative to it. So y.saturate, let's say low y is equal to y.saturate. We want to say if y is greater than 0, we need to check y minus 1. So really this is actually a filter that we care about here, and our first filter is if y is greater than 0, then y minus 1, input map get y minus 1 x. That's our first one going up. And that's an option. If it's not present, then we want it to be a higher number, so it's unwrap or U32 max. And then we can sort of get out of bounds like that, if that makes sense. In fact, let's do let mask equal, and let's just define our mask. So what we want to look at is we want to look at minus 1, 0. We want to look at we want to look at 1, 0, we want to look at 0, minus 1, and we want to look at 0, 1. So that's our masking positions. We'll use those in here. I've just listed them out here for readability. So if this is less than if this is greater than or equal to E, I guess we want to say if E is less than this for each of these. And it needs to be for all of them. So we have minus 1, plus 1, saturate, minus 1, plus 1, x minus 1, x plus 1. And then what we need to do is, we need to guard the subtractions. So the subtractions need to be guarded with y is greater than 1. And this. Actually, no, y is greater than 0, or this, because we want it to pass automatically if y is 0. Which means we want this statement to be true and we want it to exit early. And then this one here is the same. This is x is greater than 0 or this, so that it can early terminate. Right, now we just need to get our types all in the correct format. So we want to say let e equal e as usize. As U32. Let's just like unwrap everything. All copyable. E is a U8. Why is it saying expected type U32 found U8? U8 is acceptable. Oh right, I'm mapping E here. Now it just cares that we expected U8 found and U8 for what? I guess for Y1. But we want to map each of them as N as U32, and then we want to sum. So that's nice and easy. And we don't care about this or this, we only care about N. I see, it's because here we need dot copied for each of these. Nice. So let's see if this passes task 1. So for task 1, we should find 15. We need to add 1 to it, and as U32 plus 1. So for here, we should find 15. Failed. Attempt to subtract with... What? On line 40. Attempt to subtract with overflow. If y is equal to 0, this should say if y is equal to 0 or that, so that we short circuit before. Nice. Test passes. Okay, so that means we can target release util, run year 21 day 8. Get our day, that's yesterday, day 9, and get our first output. 588. Is correct. Okay, so for part 2, now you need to find the largest basins. A basin is all the locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in any basin. Okay, so you know what we can do? That's actually a good sort of improvement that they've just pointed out. You know, we don't need to do that. Basically, we could substitute U8 max for a 10 here, because they're all going to be bigger than 10. So 9s... Basically, we're looking for the regions that are surrounded by 9s. What is their size? We need to find basins. We need to find the basins by size. Okay. Okay, well, so each basin is going to have a minimum in one of those positions that we found. I wonder if we can just like flood from there for size until you hit 9s. Oh, okay. There's like a nice trick to start with. I think we should pre-process our data a bit. I'm thinking if we replace 9s with 0s and 1s with 1s, and then any other number with a 1. Basically just say not equals 9 on the whole thing. That might give us some easier data to work with. So for example, if I were to say input, is there a map in here? There is. If I were to say input.map.map n is not equal to 9, we were to have a look at that. The number we're looking for task 2 in the end is 11. Is that number there? Let's have a look at what this looks like. Hoping this is just some nicer data to work with. True, 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 false, false. In our test data, wait, what did we, true, 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 false, false, yes, okay. For now, yes, so that is good data. I think actually, rather than doing it as this, let's do it as if n is not equal to 9, 1 else 0. Might look a bit more readable. Substantially so. 1, 1, 1. Okay, yep. So now we've got regions of 0. And so now all we need to do is sort of sum all of the local regions. Just trying to think of how we can do region selection. Because I don't want to have to like... There must be an elegant way to do this. I'm going to have a think about it off camera, and then hopefully come back when I have an idea. Okay, I think the way to do this is actually to pass some information from task 1 to task 2. Because in task 1 we find all of those basins, which is useful, and part of our like input spec is that there will always be 9s between basins. No two basins will exist without like a division of 9s. So what we can do is we can write an algorithm that does a search, probably a breadth first, on a region and keeps a tally of how many things it's visited. And then we can just initialize that at each basin location. So we need to slightly modify our task 1 to have a task 1 output. And this is going to just be our, I think just a yeah, let's do this as a vector of positions, usize, and values, like that. So that's our basin values, kind of. Let's call this, let's just define it like this. And then we'll say result task 1 output, and then in here we can remove the sum and just wrap this whole thing in a task 1 output collect. And in here we need y and x to be forwarded. Y, x. Like that. There we go. And now we can do implement debug for task 1 output. and we want to do write to f a value that is self.0.iter.map, ignore the first one, n.sum. Okay, so now our task 1 has forwardable data, and we can forward it into our task 2, like so. And input now takes a task 1 output, or I will say a task 1 of task 1 output. And so that's just going to say, so now we're not recomputing those minimums in part 2. We already have them here. Oh wait, hold on. Nope, part 2 is going to take that. So part 2 is going to take task 1 output. Okay. So this is just part of the magic that I've set up with macros for writing advents of code. So now sometimes you need to forward data from your part 1 into your part 2. And we have a way of doing that. Okay. So we will say that our flood map is equal to this nonsense. And now let's write a BFS size function that takes in a map that is a array2 of just make them, they only need to be 0 or 1. I'll make them U8s and I'll sum them at the end. And a cursor position of usize. And in fact, let's say cycx. That way it's a bit more expressive about what's what. And this is going to return a U32. Okay, so our base case is that we are pointing at a 0. If we're pointing at a 0, we return 0. So if map.get cycx, or we're at the edge. So .unwrap or default is equal to 0, then we return 0. We don't have anything to add. There's no new data. Oh, and we have our value so far, which is going to be a U32. We return value. Okay. And you know what? Let's use booleans now rather than a U8. Array2 of bool. Okay. So that's our first thing, is we are going to return the current value whenever we hit an edge. Then the next thing is we are going to say that, and really this needs to just be like a mutable slice view. Is there an alias for that in here? Because I know we have like array base, but we also have array view mute. Okay, so we want array view mute 2. Oh god. Array view mute 2. Nice. This takes an array view mute 2, which presumably has a lifetime. It does, but we're not going to care about its lifetime. Okay, so this is a mutable view, and you know what? We'll do that. So this is a mutable view into our array. Yes. Okay. So what we want to do, let's sanity check this. The method unwrap or default exists, but it's not implemented for option and view.copied. Okay. So if we hit the edge, we return whatever we've summed up to so far. Nice. That's our base case. Or that will happen for backflood as well. I'm not going to take any steps to eliminate backflood. Right. So then we need to do our sort of we can say map dot get mute. Let's say let value equals map dot get mute cy cx. And then in here, what we can do is we can say value copied that. Okay. Oh, not value. Let's call it target. Okay, and so now what we can do, cannot borrow map as mutable because it is not declared as mutable. This is a view, so let's just take mutable. Okay, let's make it a mutable map. There we go. Because our mutability is in here. There's like a tick A. There's like a tick underscore. This is that. I might just put that there just so that I can see the lifetime and remember that it exists. Okay, so if our target is false or doesn't exist, then we return. And so now here we can say let target is target.unwrap. I hate doing that. Let's do that better. Let target equals if let some value equal some target equals this. If target is equal to 0, return target. Yeah. Else target. Else return. Nice. Cannot compare is false if not target. Return value. Return value. And now what we can do is we can simply remove this one here and we can say, let's format this real quick. Okay. Still don't like this, might clean it up in a bit, but for now, that gives a very nice sort of high level how to we now have a target that we can work with, which is an and mute. Nice. Okay, so we need to say target is false and value goes up by 1. That's nice and easy. But let's use a usize because we are counting here. And counting standardly uses usizes in Rust. Oh, okay, no, we just need to pass value plus 1 into our children. Right, is that correct? I guess no, we don't need to have an accumulation. Our children just need to return a value, because as long as we start in the right place, we're fine. Here there is nothing new, here there is nothing new. Okay, that makes sense. That now sanity checks. Okay. And so now what we need to do is we need to say BF size map dy minus 1. If y is not equal to 0, let sum is equal to let mute sum is equal to 0. Sum plus equals BF size map cy minus 1 cx. Sum plus equals BF size map cy plus 1 cx. If x is not equal to 0, then sum goes up by BF size of map of cy cx minus 1. And sum goes up by BF size of map cx plus 1. Cy cx plus 1. Return sum. Cy cx One of these F's should be, because breadth first search size. Let's take it mutably. Nice. Okay. So now in here we have our flood map. We have our task one dot, and we want the sum of the size of the top three largest. Okay, so we want to do task one dot into iter dot map. We want to discard. We want to keep the position. We want to keep CYCX. We want to discard the height of that position of that basin, and then we want to call BFS size on map dot. What returns one of these array mute? Array has mute. View mute. Okay. Map dot view. Let mute. Let's just say flood map is equal to flood map dot view mute. And then we pass in our flood map. And we pass in our Y and our X. And then we sort it from iter tools, and then we reverse because we want the top three, and then we take 3 and then we sum. And that gets us back a usize output. Intuiter exists on task 1.0.intuiter. Oh, really? No method name sorted found for struct iter. Why not? Let's have a look in our terminal. Wait, is it not applying our map? Our map should be discarding a bunch of stuff, right? And just getting us back. Found in map from in. No, the map is there. The method is available for it there. Oh, maybe it just didn't import. It imported the wrong thing. My bad. Now what doesn't it like? It doesn't like... I'm missing... well, I don't actually use slice, actually, because we're just looking at 4 places, so it's easier to just check them manually. Failed. We got back a 0. Cool. Why do we get back a 0? Let's have a look. What we'll do is we can debug our target for each of them, and wait, hold on. Why do we get back 0? look at the target. If it doesn't exist, then we've hit the edge. If it's a 9, then we've hit the edge. Otherwise, we have our target. We set our target to false. We begin computing our sum for the values around this target. Sum for the values around this target is equal to the sum of the things all around it. C plus. Okay. This should work. You know why? It's probably not working because I'm going depth first. This is depth first in it. Let's add back in that sum value here. And then in here we don't actually yeah, okay, you know what? Nah, sum is unmute u32. In here we just return. In here we just return. These are dead branches. Here we pass in sum. Here we say sum goes up by 1. Pass in sum. Pass in sum and pass in sum. Don't return sum. And certainly do not add sum here. We simply want to invoke the next step of the breadth first search, and this should make it actually. Is this going to go breadth first still? It'll do this. No, this is still depth first. But it shouldn't be causing itself any problems. It shouldn't make a difference. Because in here we should just say okay, we got 32 instead of 134. Let's have a look at our whole list, I guess. Collect here into a vector. And go back into an iterator after. But after the collection, I want to have a look at you and just see what's in you. Three, 9, 9, and 14. 9, 9, 4. Oh, we need to times them together, not add them together. Everyone's shouting at their monitors. I apologize. Passes, nice. And then we will just go back to our terminal and run it. And it gets us back this value here. And that is the right answer.